Enterprise AI adoption is accelerating rapidly across industries, yet actual operational integration remains stalled. Organizations are buying into the discrete tool trap. They deploy isolated chatbots, assign AI copilots to individual employees, and bolt on ad hoc OCR tools to process incoming documents. This procurement strategy fractures the company's data reality. Sales, operations, and finance end up relying on completely separate technological silos, unable to communicate with one another. While a local copilot might shave minutes off drafting an email or summarizing a meeting, it is incapable of governing or executing an end-to-end organizational workflow. Adding more fragmented applications does not result in a cohesive operating system. It simply builds faster, more efficient silos. Breaking out of this trap requires a structural shift, dividing the enterprise AI ecosystem into two distinct specialized layers. The bottom layer is the AI infrastructure. This foundation manages data integration, secures system access, and handles model routing. Sitting directly above that is the Command AI Theater. This is the human-led interface, built specifically for simulating scenarios, making decisions, and approving actions. These two layers rely on each other. The theater makes the AI's logic and options legible to human leadership, while the infrastructure ensures that any approved action is repeatable and secure at scale. Establishing this dual-layer environment allows organizations to move from isolated experimentation toward governed production. Building this infrastructure starts with the raw materials, the fragmented data scattered across ERPs, CRM systems, and live IoT feeds. Feeding this raw data directly into a large language model is ineffective. The model lacks the specific context to run a business without a dedicated translation layer. That translation layer is the enterprise ontology, structuring chaotic data into clean, interconnected nodes. It explicitly defines business objects, mapping exactly how a shipment relates to a customer, how a delay event impacts both, and the actions permitted to resolve it. This serves as the organization's operational contract. It takes complex business logic and makes it mathematically legible to the models. For organizations operating across borders, this ontology must be bilingual, mapping semantics in both English and Chinese to accurately execute regional workflows. Without a centralized ontology, AI models are merely guessing at operational context. With it, they are securely grounded in the exact reality of the business. Directly above the ontology sits the AI runtime layer, housing the specific models, AI agents, and data retrieval systems. For markets bridging diverging technology regimes, like Hong Kong and the Greater Bay Area, this runtime layer acts as a geopolitical abstraction layer. Relying on a single vendor creates severe enterprise risk. Organizations must navigate compute controls, cross-border data laws, and frameworks like the EU AI Act. A resilient, dual-layer architecture solves this by allowing operators to hot-swap AI models and compute zones. The underlying data foundation remains entirely stable. This is executed through policy as code. The infrastructure automatically evaluates the local jurisdiction and routes specific tasks to compliant data zones. True geopolitical resilience requires separating the user interface from the underlying execution layer. This ensures enterprise workflows survive shifting international technology regimes. This brings us to the human interface, the AI command theater. This environment is not an open-ended chatbot. It is a highly constrained, role-based command space designed to limit unauthorized actions. To enforce governance before any action is taken, the theater relies on a strict two-stage workflow: discover, followed by build. During the discover stage, the operator clearly frames the business problem. The system conducts deep research exclusively against internal documents, returning heavily cited answers. Only then does it move to the build stage, generating applications based strictly on verified discoveries pinned in stage 1. By enforcing a clear, auditable chain of custody from human research to AI output, these strict UI boundaries prevent hallucinated automation. To see the operational value of this architecture, consider a high-stakes scenario, managing a supply chain exception at a major commercial port. First, the system senses the disruption. An ERP flags a delay, and the ontology instantly links the specific delayed container to its precise customer obligations and route dependencies. Next, the AI runtime evaluates the ontology's predefined rules. It simulates multiple routing options and drafts a multi-step recovery plan. This interface is the human command gate. The operator reviews the proposed recovery plan, verifies citations, and authorizes action. Finally, the system learns. The decision is orchestrated back into the ERP, updating rules and playbooks with exact cost and outcome data. This continuous loop transforms a passive data dashboard into an active, human-governed execution engine. Securing this dual-layer system requires strict physical deployment boundaries. The primary boundary is the dedicated tenant. This mathematically isolates an organization's internal data, user identities, and audit logs from external networks or other enterprises. To prevent internal data bleed between departments, the architecture utilizes project local shared folders. These folders operate as isolated sandboxes. AI agents deployed within them can only read and update explicitly whitelisted files, walling them off from the rest of the organization. By enforcing these strict deployment constraints, internal AI adoption will never inadvertently bypass the organization's established data access protocols. This is the complete, fully assembled operating environment, the secure infrastructure foundation, the translating ontology middleware, and the command theater apex. Success in enterprise AI is measured by operational legibility, auditability, and safety, far more than the specific parameter count of an underlying model. For organizations operating as bridges between global markets, this architecture is essential. They demand systems capable of navigating multiple regulatory realities simultaneously, without compromise. By structurally separating human command from governed infrastructure, organizations build resilient AI workflows that outlast technological churn and survive geopolitical divergence.